I've been working recently, well, now it might be 3-4 months in my spare time on a side project called Rostra. Rostra is a peer-to-peer social network. You can think about it as a kind of a Twitter. At least that's what I'm aiming at currently in the UI, even though the underlying data structure are maybe more generic than that. In Rostra, you self-generate your identity. It's basically a secret key and a public key, and that's your user ID, and then anyone can generate theirs, and you can follow each other or not. Under the hood, the Rostra engine will download new events published by other users and make the events, the content you produce available to others, and then everything kind of nicely synchronizes, and there's a UI to display it. Might help if I just show the UI a little bit quickly. So I have some identities here saved. Let's try this one. Yeah, so this is my identity. You can see that it's already starting to sync. This user account is a test chair. One can create and post new post, look around. Yeah, it's possible to replay to other users. The post structure is a kind of a tree, so post can have a pointer to what they're responding to, and that's how you can build a kind of a conversation tree. Let's get this out of the way for now. Yeah, I want to go to more into the code part, technical parts, even if like what the project does not interest you. You might find something interesting in the architecture or a code base here. Let me just open a little helper. I have what I want to talk about. Okay, yeah, so the project is split in quite a bit of crates already. Generally, having a lot of crates in Rust makes your architecture better and your build time lower, because not only you can parallelize, but by forcing you to think about the structure of your dependencies within your project, you're gonna notice things that are beneficial if you decouple and things like that. So Rostra is the CLI tool and kind of the main binary. The client code lives here. The database of the client lives here. The core is basically the general data model. Peer-to-peer has definitions for peer-to-peer communication. Basically, actually, peer-to-peer here is just a peer-to-peer networking code, which is basically just wrapper around IRO. Peer-to-peer API are the data types. Rostra util is some just general purpose utilities I had to add for, like, I don't know, error handling or things like that. The loop chain is like, I'm using a special channel in one place that has very uncommon semantics. Not very complicated, but just something I had to run myself. Utilities for errors, utilities for formatting. Web UI is where the web UI lives. Let's look at the core. Yeah, so for serialization, Rostra is using heavily Bean code because it's compact and relatively fast, and most types in Rostra don't need the serialization to be self-describing, so we can save some encoding size by using a format like that. A lot of types are just array of bytes. For example, this is an event ID, which is 32 bytes of a hash of the event. So I have a macro here to define it for me. Maybe we should probably start with a event. Yeah, maybe I should make it slightly smaller, just so we can see more. Yeah, so event is kind of the core of Rostra. Everything that is being published is published in form of an event. Event has a version, which is a single byte in case there's ever a need to change the format of an event, so the network can migrate smoothly. Event can also have flags, which have we can have certain meanings. Right now, there's only one bit in that flags that means delete previous event. So if anyone published something that they would like everybody else to not look at anymore, because they either fixed it or it was a mistake, they can publish another event, and that event will set the delete flag on itself and point at the event to be deleted. And that's very kind of core functionality to track what content was deleted. So all the well-behaving clients will respect the bit flag and just delete all the events, saving space, and so on. Then events have kind, and it also goes into directly into event data structure. I should have mentioned it earlier that event is pretty small. It's what was it? I think it's like 128 bytes or something, or maybe 96. Yeah, I think it's like 64 plus. Yeah. It's pretty small. It actually does not contain the content. That's my main point. The content itself is a part of a different structure and is being tied to the event through its hash, cryptographic hash. This way, events act like a header that clients can synchronize between each other very quickly. And then the content of an event can be arbitrarily large. So in Rostra, you could put a whole movie, even a gigabyte file, as the content of your event, and then the event would point to it by hash, and then clients can decide to download something or not based on its kind and size and other things. And then if someone posts things that are heavy, then they might get more aggressively garbage collected by people that look at their content. So yeah, because of that, the content is committed by both its hash and its length. So when scanning through the events, it's possible to tell if something is if the content of a certain event is something quick to download or maybe not so much. Maybe it's, instead of eagerly downloading it, it's better to make it lazy, on demand. Yeah, so there's a kind, how long is the content that this event carry with it. There is a timestamp, there's some padding that is currently not used for anything, just left to kind of make the size of event more aligned to the power of 2. Every event is supposed to point to the previous event, so-called parent event here, and this is supposed to be the latest event the given client knows about. But there's also an auxiliary parent. An auxiliary parent can either have some specific meaning. For example, if you set the delete flag in the flags, the auxiliary parent will point to the parent that is being deleted. It's marked as deleted. If there is no specific meaning, then auxiliary parent can be set to a random previous event. And the reasons for two parents is mostly to have the history of a given identity, so all the events it produced be structured as a DAG. When the client is downloading the history, it can fetch the latest event and then immediately gets the pointer either to the previous one, so it can one by one follow the whole history, and the other pointers that point to some other parts of the history. This allows parallelizing processing, because the random event can point to event from like a year ago or whatever, right? And then that, if you download that event, then you're gonna get more pointers to arbitrary places in the history. But so if you want to employ parallelism, you can start downloading history in multiple places and eventually kind of synchronize everything and in kind of random chunks. And yeah, and the last field is the content hash, which is just a cryptographic hash of a content associated with event. Yeah. So the clients in Rostra basically try to figure out and publish their own latest event, and then follow the event history and download the content associated with the given event. There is a structure called event ID, and that's basically the hash of the event itself, as opposed to the hash of the content, which is a different thing. Yeah, if we look at the let's look at the Rostra core, at the files here. Yeah, we have events, we have content, we have some subcrates that define serializations either in kind of SERDI or Bean code. Yeah, let's look at this. Right, the event content in Rostra, at least initially, is just the arbitrary array of bytes. After someone knows its content, what is it? Event content? Is it here? All right. Content. Right. This content, this array of bytes, can be deserialized based on an even kind that was specified in the event. So what event kinds we have? So, for example, following someone is an event kind. So we publish an event with a kind follow. I think that's the name for it. Or here, this one. It's just a U16. Yeah, and then the content associated with that event is going to be a CBOR serialization of this data structure. CBOR is used so it's possible to add fields over time, allowing kind of easier evolution of formats here. Yeah, CBOR is kind of like JSON, except a little faster to parse and a little faster and a little smaller in serialization. Yeah, so it's a self-describing format, and that's larger than bin code would be, but it's unnecessary to track kind of all the versions of the serialization. One can just use optional fields. So let's look at the types of events that are already here. So there's a null, which means it doesn't contain any content. There is raw, which is kind of an escape hatch for there's a bunch of bytes here and it's not specified what it is exactly. Currently not used, but just reserved it for the sake of it. Follow and unfollow, this is for like the social aspect of Rostra, because in Rostra the social graph ties directly into peer-to-peer communication and replication. Basically, the people that follow you will download and replicate your history of events, acting as a redundancy as well. So if you lose your data, your followers still have it. You can replicate your events from your followers, and other people that know that someone is following you and they would like your data can potentially download your history and events and their contents from them instead of you, in case your node is currently not available. So this way, the more important / popular you are, the more times is your data replicated on other nodes and more available it is. Persona, that's another whole story. I think I'm going to skip it for the sake of brevity. Node announcement. So underlying peer-to-peer layer uses IROH. IROH has a concept of a node ID. So when you create a new instance of of a node for your identity, it will generate the IROH identity for itself. And then your own nodes, because you can have multiple of them, you can run your Rostra node on a server, you can run one on your desktop, and they will synchronize between each other. So they will publish their ID as a part of the history. So this way other users can know which nodes they can query. If someone is trying to download your events, they might try to connect to any of your existing nodes that already announced themselves. This is a social content. So this is mostly what's visible in the UI. So you can make a post. Actually, I don't think we're using likes. I think even reactions are now posts. Repost. I think those two are actually not used. I was planning to use them, but they don't exist. There is a profile, so you can publish your profile. And if we look at the post, okay, where is it? Here, social post. So this is the serialization format of a post. So everything you post is, at least it's supposed to be eventually be associated with a SIPE identity. It's like a personal or professional or like one of your hobbies or your political post or something. Then it has a content in Rostra is in DJOT, which is kind of like Markdown, just to get the good blend of formatting without too complicated data formats. It can be a reply to an external event. An external event is basically someone else's identity and short event ID. Events are hashes, Blake 3 hashes, but these are 32 bytes. It's kind of unnecessary to send all the time everywhere 32 bytes just as an ID of a something like a social post. So it's being shortened to 16 bytes in many places, like in database. So then when you want to identify someone event, you can identify it by their ID and short event ID. 16 bytes, their collision, the space is still so large that it's impossible to create a accidental collision between two events. You could do it by grinding a lot of contents and looking for it on purpose, but if you did it, it wouldn't, like, it would just ruin your own event, like your own history, maybe cause problems for people to try to sync your history, but it wouldn't affect the rest of the network. So for the purpose of space savings, oftentimes the event ID is abbreviated to the short event ID. Some posts can be reactions, just like an emoji, like a like or a heart or something. In Rostra, you can make an arbitrary reaction. Yeah, and it's just like an optional field on the response, just to keep everything within one kind of a content. Yeah. So you went through events and the content, the IDs. So let's look like Rostra ID maybe. It's basically 32 bytes, and since there's multiple of those, there's like a simple. All right. Yeah. It's here, I think. Yeah, so this will define like a struct, a new type over a given amount of bytes, and give it some basic methods, just so I don't have to repeat it for many structs here. So there's a roster ID, there's an event ID, there's a short event ID. There's some others, but they're not very important. Yeah. If we look at crates, Rostra, one underline, like a big part of Rostra is the database, because it comes down to downloading events, deserializing them, and then tracking relations between them. Like which event do we already have, which ones we're missing, which content we want, which content we were able to get. So the Rostra database code is pretty wide. Like there's just a lot of things to track. Under the hood, Rostra is using RedDB, which is like a embedded key value store. It's implemented in Rust, which is nice because I don't have to deal with any C or C++ libraries, like if you were using SQLite or RocksDB or something like that. Worked well for me. I have implemented my own wrapper around it called RedDB bin code, because by default RedDB has some facilities to define types of keys and values you store, but I wanted just a general purpose bin code types, so I can define types. Let's maybe it's gonna be clear if we look at tables. So RedDB has concept of a table, which is like a named namespace of keys and values, where keys and values are decoded and encoded to bytes. There is a little macro here that defines some constants for and those constants work as a table. And for example, there is a table called db versions, and it maps from nothing, meaning it's a singleton, to the current version of the schema, and this is used for migrating data in those tables. I can show the migration code later. ID self, also a singleton for information about our current, like the ID that owns this database, your own identity. Then there is a IDs full. There in certain places it would make sense to track just the prefix of a Rostra ID and be able to map it to the full one. Not very important. IDs nodes. This tracks the announcements of IRO endpoints that belong to host given identity. So as we discover them, we discover where to get events from a given identity. We store them here. This is a social graph. Basically, this means that this identity follows this one, and this is the opposite. This identity is being followed by this one, and depending on the need, you might want to discover this relationship one or the other way, and then those values here can track extra stuff. When it's possible to unfollow someone in Rostra, and that just publishes a new record with a newer timestamp that says I no longer follow this identity. So then the record here, the records here would be deleted, and to track the timestamp, the fact that someone was followed and then unfollowed is also recorded. Personas, again, let's skip it. Then events, a short event ID is mapped to the event record, and this is signed event, which is event plus the signature over it, so that the events are authenticated. And we already looked at the events, so this is probably one of the biggest tables here, at least by the number of records. Every event generated by anyone we're tracking is there. We track the events that we're missing. So if we downloaded event that pointed to another event, and we don't have that another event yet, we'll store the list of those so we can look for them later. And heads are the latest events that don't have any children, like any events pointing at them. So they're kind of like git head. I think that's the right way to look at it. And because users can host nodes on multiple devices, they actually can have more than one head at the time. The nodes, when they notice that your identity has more heads, they will produce a new event that merges those. So this is how the synchronization between devices is achieved. Like you can post at the same time from your one device and the other device, and those histories will just get merged by another event, and the merging event will point to one and the other. So everything tries to converge on the one head, but for brief periods of time it can the heads can be divergent, or like there's multiple of them. Event self, I don't even remember. Oh, these are IDs of events that belong to us, to the owner of this database, right? Just because it's often necessary to go through your own history. Events content, this is where if the node decided it wants a given event, it will download it and store it in this table. Content missing are the events that we would event content is the content for events we would like to have, but we weren't able to get it. So this is also used for tracking, just so there is a task in the node that goes over those and connects to other peers trying to get that event over time. Here you can see like there was a migration here, so this table used to look like this, but now it looks like that. So the old structure is still there and it's used in a migration function. Same with posts. So profiles are basically social profiles. Like we want to know what is the display name. Like we don't want to see this long public keys. If someone wants to be called this, they can publish event. We can actually look at the content here. So there's a display name, there's a bio, and there is a avatar, which is like just like the mime type, and bytes, so it can be like a JPEG or whatever image that people want to use their avatar. Posts, we track replies. So when you look at the post, you might want to show all the comments to it. So to be able to quickly look them up, there is a separate kind of an index table. Same with reactions, so you can display kind of emojis. Here are posts by time if you want to go chronological over the events, which is useful for like the timeline of like social posts. So this is pretty neat here. It kind of works a little bit like SQL table, kinda. You can think about it this way. Let's look at migrations. So so migration call will just read current version, and if the current version in the code is this is like that's why I got confused, because the operator. So this is gonna fail if like you're trying to run the old code on the database that is already on the newer format, and here we'll run migrations for every time the database version was incremented. So the first migration renamed social profiles table and then copied over the data and deleted old table. This will actually get kind of optimized in a newer version of RedDB. Similar migration v1 was rewriting social posts to new format. So that would be migrations. Let's look at the crates again. So there is quite a bit of code for like networking, peer-to-peer, RPC between nodes, but that's not all that interesting. I think I would like to look at the web UI. So web UI is kind of a web server. Where do we start this guy? That comes down to starting Axiom server. This server has a state. Where's the state here? There we go. There's a state. Shared UI state, and the state is mostly just multi-client, and multi-client means on the one web server you can open multiple Rostra clients for different identities. So this is useful for hosting public instances of Rostra, where you might want to let people just use their identity. You can host other people's identities, and this way it's possible to run multiple clients from behind a single web server. Yeah. One thing I really like here is the usage of MAUD. Let's see if we have any MAUD. Yeah, so I really like working with MAUD templates. Very fast, and I can use whatever Rust code inline without any. So I want to render profile summary, I put it in a different function, call it with right arguments, and render the whole thing as a response. So I can make arbitrary composition between parts. I just define a function that renders this widget or that button and then glue them together. And on top of it, since HTMX is being used, it's really easy to embed reactivity in this hypermedia. Like this is the whole point behind HTMX. It's like I can render a button and embed kind of its interaction with a server inside. Where it would be a nice place to, probably in timeline. Where's the new post form render? Oh, this is render main bar timeline. So let's maybe quickly go through how it works. So we have some pagination that is passed as kind of a query argument, and we read from database that the chunks we're supposed to display 30 at the time. We use the filter function to pick the post we actually want to display, because some of them might be reactions or replies. There's a little bit more logic behind to format it well. We download parents for those posts in case they were responses to something, and then we return like the rendered page where we format a bunch of things, and then if there were more posts, we're just gonna render a div element that when it's being shown, it's gonna make a query for more events. And this is how, for example, you achieve kind of an infinite scroll, that as you're showing the bottom of a page, it makes a request to the server with an ID of the next post to fetch from, and replaces itself with that, and that will in turn will render this div again with an updated cursor in the history. And it works really well. And I think at certain level of complexity, which most web pages wouldn't hit, it might be difficult to track interactions between everything. But the level of complexity for something like a Rostra/Twitter interface, it's very adequate and very simple. And the fact that there is no serialization layer between server and client makes things very simple to tie together. Like you think about the UI as a hypermedia document, and you just keep rendering chunks of it, and interactions are just getting more chunks of it, or switch to a different document and stuff like that. So I'm very pleased with how that went. I think this video is kind of long already, and I went through most of the stuff I wanted to. So thanks for listening. Bye.